Solve y equals 3 cosine 2x for x, where x is restricted to the interval 0, pi over 2. So to solve this, we want to isolate the cosine of 2x. So we have the equation y equals 3 cosine 2x. I divide each side by 3. Y divided by 3 equals the cosine of 2x. And now I can say that 2x is equal to the arc cosine of y over 3. Finally, I can divide each side by 2 to get the value for x. So x would equal 1/2 arc cosine of y over 3. Now remember, we can write that using the inverse cosine notation, and so we can write it as x equals 1/2 the inverse cosine of y divided by 3. Now because y equals 3 cosine 2x is a periodic function, we were given restrictions on the possible solution. So let's take a look at the graph. And remember that we were told to restrict it from 0 to pi over 2, right here. That 0 had to be less than or equal to x, less than or equal to pi over 2. And here's y equals 3 cosine 2x, the full graph, but the blue section is the restricted section. And what that means now is by doing so, this function would be a 1-to-1 function. And therefore, since it has a 1-to-1 relationship, we know that we can get simply one value out of the function for each one value that we put into the function, which is to say that each y value substituted in will lead to a single x value.
Let's solve an equation. We're going to solve 2 arc sine x equals pi. I want to isolate x. So as a first step, I'm going to divide each side of the equation by 2, which leads me to arc sine x equals pi over 2. I'm interested in solving for x. This is arc sine. To undo the arc sine, I apply the sine function to each side. Applying it to the left will leave me just x. Applying it to the right leads me to the statement sine pi over 2. Now the sine of pi over 2 is 1. So the solution to the equation is x equal 1, and I can write that in solution set notation. Let's solve an equation involving inverse trig functions. We want to solve inverse cosine of x equals inverse sine of 1/2. The first thing I'm going to do is isolate x by undoing this inverse cosine. The way that we do that is we apply the cosine function to each side. That'll leave me with x on the left, because the cosine of the inverse cosine, they undo each other, and I'm left with x. But I'll have to figure out what to do with the cosine of the inverse sine of 1/2. Now every time you see an inverse trig function, I want you to think that that's some angle. So let me call that angle u, and I'm going to sketch the angle whose sine is positive 1/2. In a coordinate system, here's my angle u. Now I want the sine, which is the opposite over the hypotenuse, of that angle to be 1/2. So I've labeled the opposite side 1 and the hypotenuse 2. That leads me to the third side, being the square root of 3, either by the Pythagorean theorem or you might recognize that triangle. What I'm really interested in, though, is the cosine of this angle. I want the cosine of u, which is the adjacent side, over the hypotenuse, or in this case, square root 3 over 2. So x must be square root 3 over 2, and that's the solution. In set notation, the solution is the square root 3 over 2. Let's solve an equation. We want to solve arc sine x minus arc cosine x equals pi over 6. Well, what I'm going to do as a first step is isolate arc sine x by adding arc cosine x to both sides, which leads me to arc sine x is equal to arc cosine x plus pi over 6. I'm going to isolate this x on the left at this point by finding the sine of each side of the equation. Now the sine of the arc sine, the two functions will undo each other since they are inverses, and that will leave me with x. But on the other side, I'll have the sine of the arc, need an extra c in there, arc cosine x plus pi over 6. To continue with the right-hand side, which is what I need to focus on for a few minutes, I'm going to have to apply a sine sum identity. Arc cosine x is an angle, plus pi over 6 is an angle. So for the right-hand side, applying that sine sum identity, I'll have sine arc cosine x times cosine pi over 6 plus cosine arc cosine x times the sine of pi over 6. And I need to continue from there. So let's move to another sheet. I need to think about a way to write in terms of x, sine arc cosine x and cosine arc cosine x. And I'm missing some c's on my arc cosines. Now arc cosine x is an angle. I'm going to call it an angle u. And these are both the angle u. And I'm going to sketch my angle u in quadrant 1. So here's my angle u. I want it to be the angle whose cosine is x. So I'm going to make the adjacent side to it x and the hypotenuse 1, which means the opposite side by the Pythagorean theorem should be 1, or the square root of 1 minus x squared. And I'm going to come back to my statement and replace the sine of my angle that I've drawn with square root of 1 minus x squared over 1. So I'll have x equals the sine of angle u, square root of 1 minus x squared over 1, times the cosine of pi over 6. So I'm going to go ahead and put in the square root of 3 over 2 for that, plus I need the cosine of my angle, which is x over 1, times the sine of pi over 6, which is 1/2. What I have at this point is an equation that's entirely in terms of x. To continue from here, I'm going to go ahead and clear the denominator 2 by multiplying every part of the equation by 2, which leads me to 2x equals the square root of 1 minus x squared times the square root of 3 plus x. I'll subtract x from each side, and that'll be 2x minus x is equal to this. Let's go ahead and do that. 2x minus x is x, and that's equal to the square root of 1 minus x squared times the square root of 3. At this point, I want to square both sides to get rid of the radicals, and I'll end up with x squared is equal to 3, and I'm going to put the 3 at the left of that side of the equation, times 1 minus x squared. I'll distribute 3 to get x squared equals 3 minus 3x squared. I'll add 3x squared to each side, so 4x squared equals 3. Divide by 4, x squared equals 3/4. At this point, I need to take the square root of each side of the equation. That'll lead me to x equals positive and negative the square root of 3 over 4. There is an exact square root of 4, but not of 3, so I can write this as plus or minus square root 3 over 2. Now, since I squared both sides of the equation at some point, I need to check both of these solutions in the original equation. If you check each one, you'll see that negative square root 3 over 2 does not check, but positive square root 3 over 2 does check, which leads us to a solution set that just contains positive square root 3 over 2.